Expanding Mind. I'm your host, Eric Davis, continuing our conversations about the cultures of consciousness. It's great to be back at PRN. Of course, there's some technical difficulties over the last few weeks. Seems whatever weird karmic storm has brought terrible cold to the East Coast decided to extend a little tendril of chaos to our studio honchos there, who have been working valiantly to return the station to its rich, full-bodied presence in the world. And so I'm very grateful for that, and of course for the continuing existence of the Progressive Radio Network. I'm also happy to be back with some news. I have finally relaunched my website, which has been moribund for a number of years as I go through graduate school and got tired of the interface, and it's been lovingly refurbished into a handy-dandy WordPress format. And so tons of my old articles and new talks and some new stuff that's coming out are available there. It's at Techgnosis, TECHGNOSIS.com. And one of the recent posts is a talk I just gave at this for the Psychedelic Society of San Francisco called Psychedelic Culture at the Crossroads. And in that talk, I try to I'm engaging sort of the tremendous changes and new dynamics and new conflicts, actually, that are happening inside the world of psychedelics. It's been something that I've been following for many years, from a lot of different angles. And of course, few people listening to this podcast will be surprised to hear that there's a tremendous amount of change going on with the so-called psychedelic renaissance in official above-ground scientific research, psychological research, and a real sea change beyond that sort of narrower world of research and regulation onto a real shift in the society at large. I think that part of the shift that we're seeing with cannabis in the United States is sort of having a nice echo effect with psychedelics. I think a few weeks ago, Michael Pollan put out a story in The New Yorker, and of course Michael Pollan usually writes about food issues and has mapped out already a kind of interesting terrain and has written about cannabis, for example, before it was such a hip thing to do. So he's sort of a fellow traveler, as it were. And his article, The Trip Treatment, really talks about gives kind of an overview of some of the issues in the new psychedelic research, the so-called psychedelic renaissance. And one of the people that he talks to is Doctor Robin Carhart-Harris, who I'm very happy to say is our guest today on Expanding Mind. So we'll be talking to him in just a second. The reason that he's on the line with me today is pretty exciting. Dr. Carhart-Harris is a research associate at the Imperial College of London, and a number of years ago he was the lead on a study of the effects of psilocybin on the brain, a fascinating study which we'll talk about more this hour, that really for my money is the most interesting of any of the research findings since the return of psychedelic research, in terms of the insight it gives us into the action and some of the speculative possibilities, ways that we can think about what is the meaning of the results of this research in terms of how psychedelics function, how do they relate with other states of consciousness, and what sort of things might they be good for in healing and psychology and otherwise. But even more exciting, potentially at least, is the new study that Dr. Carhart-Harris is involved in, which is the world's first imaging study of the brain on LSD. And in addition to an incredibly worthy goal, here's this tremendously powerful substance that, whatever you want to say about its efficacy for psychological insight, is an extraordinarily powerful activator of consciousness. Well, what's it doing? How's it working? Well, how can we bring the best tools we have of understanding what's going on in the brain and at least map what's happening in real time as somebody goes into a journey? And in addition to the the coolness of this study, it's also very interesting because it's being crowdfunded. And the campaign has just begun. It's on a new, at least new to me, crowdfunding site that's focused on science called Wallacea, WALACEA. And I think they were aiming for 25,000 pounds, and in the first couple of days they're up to almost 43,000 pounds. So I think this study's going to do pretty well, and it's a good sign for crowdfunded science in general. So I'm really excited to hear about the new study and to talk to Dr. Carhart-Harris today. So before we bring him on, of course, we got our co-host here on Expanding Mind, Maja Daou. Hey, Maja.
Hi, Erik.
How's it going?
It's going really good. I'm so excited. We get to even have this radio show today. It's so good that how much is changing on these fronts. I know we always talk about it on the show, but thank God someone's finally doing these studies on LSD. It's like cowboys just want this information, so they're going to do it themselves, regardless of stigma or poo-pooers or naysayers. So really, it's like a miracle to me that this is getting crowdsourced and people are getting this information. It's very, very exciting.
Yeah, and it's just also wonderful timing that even as regulations loosen in the United States, in the UK, and in other countries, that doesn't mean that the monies that are necessary to perform research are available. Drug companies aren't funding this stuff. A lot of people don't want to deal with it. They don't want to touch it with a 10-foot pole because they're still illegal drugs. There's a great stigma against them. Some of the letters that the New Yorker got after the Michael Pollan article were from, doctors who were really concerned about the dangers. And, there's a kind of whole, to some degree understandable concern. And so it's marvelous that we're also at an era, of crowdfunding, which to my mind is one of the best social, positive social features of the internet as we have it now, and so it's a really remarkable time where, in some sense, science can start to reflect interests beyond a narrow world of corporations and institutions with very particular kinds of agendas. So I'm very very excited about that.
Me too. Thank goodness.
All right. With no further ado, let's bring Dr. Carhart-Harris onto the show. Robin, thanks for joining us at Expanding Mind. Do we got you?
Hello.
Hello. Hey, that's a nice, clear signal.
Oh, good.
Well, congratulations on the success so far of the study. It seems like people are really responding a lot to this to the new possibilities of this study. And I'd just love to hear a little bit first about this study, and then we can maybe talk a little bit more about your earlier work and some of the theoretical possibilities. But really, why has it taken so long to do something that in some ways is relatively simple, which is, use our great some of our tools, our scanning tools, and just look what happens with the brain on this powerful, consciousness changer?
Well, it's a good question. Why has it taken so long? Well, one thing is it is expensive, so it's not that straightforward for people to have money to fund this kind of research. And also, you've got to think, where's that money going to come from? And there's a stigma around LSD and psychedelic drugs. There has been for a while, although I think attitudes are changing about the drugs. And I think that stigma has sometimes been an obstruction to big funding coming in for this kind of research, funding from established bodies, perhaps funding coming in from institutions. I think, certain people might be of the view that, should this institution, should this, established funding body, be funding research into the effects of LSD? Is that really something that's worthy of our attention and investment? And of course, I think that's completely wrong, and that LSD and other psychedelic drugs are incredibly powerful tools for understanding the mind and the brain. They also seem to have a huge amount of therapeutic potential. And so, of course, my view, and thankfully, I think the view of the people who've supported our crowdfunding campaign is that, they share this view that psychedelics and LSD are really valuable scientific tools that could be very useful in a number of different contexts.
Well, I have a question about we often ask questions about the sort of sociology of science on this show. We kind of find ourselves with these topics often. And, I know that one of your colleagues, your Professor David Nutt, he's a very well-established character. He's done work for the government. You're a younger researcher. You came in, you had your own background, and you were deciding what direction to go. I'm curious. I mean, when you thought about your desire to pursue this particular field of inquiry, and before you had the breakthrough with the psilocybin study, which got a lot of positive attention, really produced some really excellent science. It must have been a little dicey for you. How did you feel about weighing like the sort of needs of your sort of professional needs and your personal interests, and trying to figure out whether this was an appropriate time to pursue these somewhat heretical topics? Yeah,
well, it's been an interesting road, and it hasn't always been easy, and it's required a bit of self-funding. My PhD was self-funded. I wasn't able to study exactly what I wanted to do straight away, but who is able to do that? Often you have to get your foot in the door somewhere in order to get to where you really want to be. I was fortunate in finding David Nutt, and I'd actually proposed when I met him. He was kind enough to give me an interview when I was doing a master's in psychoanalysis, actually, and he agreed to see me, and I went to Bristol where he was a professor, and I said I want to do a brain imaging study with LSD. I want to do an fMRI study. And I told him why. I had a certain hypothesis that the brain on LSD might look like the brain during dreaming, and that this would tell us interesting things about the neurobiology of both states that may help us not just understand the neurobiology of both states, but also the psychology, that there are common aspects to the psychology of the psychedelic state in dreaming. Anyway, so this was my idea, and it was a bit much to be. I was a bit naive to think that I could do that for a PhD, but nevertheless, David, being the character that he is, heard me out and didn't shut the door on me. He said, "Are you interested in sleep?" Which I was, and are you interested in the serotonin system? And yes, I was. And he said, "Why don't you talk to my colleague, and maybe you could do something else?" And so that's what I did, and I did that for my PhD. But it got my foot in the door, and I remember at the time when David had said I couldn't do this LSD imaging study, I felt quite disappointed and a bit deflated. And I spoke to someone who said, perhaps you have the wrong attitude here. It sounds like it's gone well if he's suggesting an alternative project, and this could be an opportunity for you rather than it maybe a door opening rather than a door closing. And that's how it's panned out. So
that's great. Well, why did you end up? Why did the psilocybin study arise then? If your interest was always in LSD, how did it turn out that the first kind of major brain imaging study was on psilocybin?
Yeah, I think just with a bit of time and a bit of reading, in a way, this kind of gestation period, I suppose, during my PhD allowed me to think things through. I befriended a psychiatrist who was also interested in psychedelic drugs, and together we came up with another idea around looking at psilocybin to treat alcohol dependence. This was around, 2007, 2008, and we proposed it to David Nutt's team. Again, it didn't get a green light, but that was a useful exercise. And during that exercise and thinking about things, it seemed logical to propose going with psilocybin, and the reason being there had been some modern research with psilocybin. Franz Vollenweider in Switzerland had done some quite a lot of research with psilocybin around that time. So there was a greater body of at least modern research looking at psilocybin rather than LSD. Also, LSD still carries this unfortunate stigma again. I think people are a bit scared of LSD. There's something about those three letters that seems to attract sensationalism and alarm for whatever reason. And psilocybin, most people don't know what it is, or at least the man in the street doesn't really know what it is, and so for that reason, it was a little less scary. So we thought for funders and other people, and so that was kind of the rationale. Really, it wasn't that we thought psilocybin necessarily was the better drug, although this isn't strictly true. But the drug being something that does truly occur naturally, there's something about that seemed a little more appealing than LSD, which is semi-synthetic, shorter duration of effects with psilocybin. But it was a combination of things, a number of things really that sort of supported looking at psilocybin. And as I said, we were proposing to look at it in alcohol dependence, but there'd also been a bit of brain imaging work done by Franz Vollenweider on psilocybin, and so again we could reference that when we were going for ethics approval. There was also a paper on intravenous administration of psilocybin, and I'd recently become interested in another study looking at the effects of intravenous ketamine, and I thought that ketamine study was a particularly elegant design and model, and I thought, if intravenous psilocybin has been given in modern research, then maybe IV psilocybin could be used in a modern brain imaging study. And so that's kind of how things evolved, really. And we did this pilot study, so a preliminary study before throwing anyone into a brain scanner, where we injected people with psilocybin in a non-scanning environment to look at tolerability and basic physiological parameters, just basically seeing how safe the drug was and how strong the effects were. Kind of a safety study, really, and we were doing that ahead of giving anyone intravenous psilocybin in the scanner. That's always been the way we proceeded as well. So, for example, with this LSD brain imaging study that we've done recently, there was also a pilot phase before that where we gave different doses of LSD outside of a scanning environment and did a number of different physiological measures. And
yeah, that would seem to be necessary, given at least you want to make sure everybody's aware of what's going on before you put them into a scanner, almost guaranteeing some peculiar science fiction experience.
Yeah, but you have to do things stepwise. You got to walk before you can run.
Exactly.
Yeah.
Well, I know you've talked about this tons, but I think it's really important to go over the sort of major findings of that study, and to some extent some surprising findings about shifts in activity in the brain, and particularly this PCC area that's associated with the sort of default mode network. And if you could talk a little bit about those terms and what they mean, I think they're very significant.
Yeah, sure. So what's interesting is that when you do a study and you get results, you've got this very rich kind of treasure chest, really. You've got so much there, but it takes a little while for things to kind of settle and for the kind of the sort of explanation and interpretation of the data to begin to sort of crystallize, and that's even though we did this study in 2011, I think it was completed, it's only really recently that I sort of feel like I have a firmer understanding of actually what it was that we saw. And so to talk a little bit about some of the findings, one of the most consistent findings in our brain imaging work with psilocybin has been a change, I would say, in the quality of brain activity. And I think some of the sort of slight confusion perhaps, and perhaps misunderstanding of the brain effects of psychedelics has come around trying to understand quantitative changes in brain activity and what this might mean. For example, does brain activity increase or decrease? And the problem with that question is, what do you mean by brain activity? And that sounds a little bit like a sort of irritating thing to say, but these things aren't always that well defined, and the different measures you get, you're not always clear what they actually mean. So what we're finding now is that a better way to understand the effect of psychedelics on the brain isn't to focus your thinking or your questions around changes in quantitative changes in brain activity. For example, are there increases or decreases in X measure of brain activity, but rather what is the qualitative change in the brain activity? And when we start thinking about things in that way, there's a very clear dimension on which we see consistent changes, and that dimension is one that, if you can imagine in your mind's eye, you have at one end disorder, and at the other end order. And here we're describing the nature or the quality of activity within a system, and this system is the brain. So is brain activity more ordered or disordered? And ordinarily during health, the brain actually resides in an optimal point between those two extremes. If the brain was too ordered, there would be no flexibility to thinking. Thinking would be too rigid, too narrow. Thinking and behavior would be inflexible. It wouldn't be dynamic. It couldn't respond to an unpredictable environment, and that wouldn't be evolutionarily optimal if you were rigid in that way. But to the other extreme, if thinking and behavior was too chaotic, if it had no structure, then again that would be evolutionarily disadvantageous. People would be simply too chaotic. Now in health we reside in this sort of optimal position between these two extremes, and what psychedelics seem to do is move the brain actually towards the extreme or the pole of disorder. So it moves the brain from an optimal position between order and disorder towards disorder.
Can I ask you, did you guys find if that activity was localized to any particular area of the brain? That might be kind of a weird question, but Could you find where the activity was, or was it just kind of all over the place?
No, that's a really good question, and it is localized to a particular region, and it was mentioned that the PCC region has been implicated in how these drugs work in the brain. So the PCC is, when you spell it out, it's the posterior cingulate cortex. And what's interesting about this region in the brain is that it's seems to be a very important cortical hub structure. So that means that it has very dense connections. So there are a lot of neural projections into the PCC, and there are a lot of projections coming out of it. So it seems to be a really important information integration center. It's also especially metabolically hungry. It consumes more glucose metabolism it consumes more glucose than elsewhere in the brain. And it's also more heavily perfused, or it receives more blood flow than elsewhere in the brain. So it's a particularly, active, buzzy kind of center in the same way that a capital city is, or a major train station or airport. It's a center of activity, and it's also a center for people. I say people. It's a center for different lines of communication to come together into this common center. In the same way that certain websites have a lot of traffic, like Facebook or whatever. So what would it mean if you were to, metaphorically speaking, blow up a capital city? And that's kind of, it's a bit of a loose metaphor, but that's kind of that's one way you could understand what psychedelics are doing, because they're disturbing the normal order or organization, particularly in this hub structure and other cortical hub structures. So they're creating a kind of disorder in these hub structures, and you by implication, if you were to do that in a really important organizing center, then that would have implications for the entire system. If you were to blow up a capital city, it's sounding a little bit morbid, but that's going to have implications for the rest of the country. It may invite an anarchy. It may.
So it seems like it actually, that would be a good metaphor, because it seems like it actually kind of structurally, in terms of like electromagnetic activity, I guess at least, would have like a real palpable change on the brain, correct?
Oh, absolutely. Yeah. It's a very marked effect and quite reliable as well. So we've used different imaging modalities and seen effects localized to the same regions. The PCC particularly has been quite consistent. We've seen it with psilocybin when we've used fMRI, a brain imaging technique that uses a very strong magnetic field in order to look at changes in blood flow in the brain, essentially. So we've seen changes in the PCC when we've used fMRI, and we've seen changes in activity. Again, changes in the quality of activity, such that activity is becoming less ordered. It's becoming more kind of scrambled, I suppose. And we've seen that with another technique called magnetoencephalography, or MEG, which measures oscillating neural activity.
Yeah, I wonder if you actually if you could explain that imaging technology a little more, because that's one of the ones you're planning to use for the LSD study, and I know less about it, but it also seems to point towards the sort of larger scale electromagnetic sort of wave-like patterns or vibratory patterns across the brain, which strike me as being a particularly fruitful avenue for looking at some of these changes.
Yeah, one of the real merits of the LSD design is that we're using fMRI and MEG, and one of the reasons for that is that they're complementary. So what you don't get with fMRI, for example, you do get with MEG. So, for example, with fMRI, you are unable to record the very fast oscillating activity in the brain, essentially the electrical activity. That's essentially what we're measuring with MEG. So with fMRI, you can only really record up to a couple of seconds in terms of the temporal resolution. So it's quite a slow, sluggish signal that you get with fMRI. And with MEG, we can record up to 100 hertz, really, which is a signal fluctuating up and down, oscillating up and down, 100 times in a second. So it's quite rapid activity. So we have a much broader temporal resolution, a much finer grained temporal resolution, or a higher resolution in the dimension of time with MEG than we do with fMRI. But like I said, they're complementary. So what you don't get with MEG, you do get with fMRI. So with MEG, you can only really record activity in the cortex, or the outer layer of the brain, that kind of convoluted surface that we see when you actually look at a brain. So that's the cortex, that sort of outside layer. And we know that in humans that's very expanded. We have a much larger cortex than other animals, and that's really what sets us apart. So MEG only really records activity. It's only sensitive to activity in the cortex, whereas fMRI can measure activity in the whole of the brain. So it has this depth resolution, and it has this superior spatial resolution to MEG. So we can look at activity in quite small voxels or cubes of brain matter with fMRI. In the domain of around about a few millimeters, whereas MEG we don't have that kind of spatial resolution.
Wonderful. Well, thanks for that explanation and clarification. We're going to take a break right now. We're talking with Dr. Robin Carhart-Harris about LSD and psilocybin research, and we'll be right back after these messages.
Welcome back to Expanding Mind on the Progressive Radio Network. I'm Maja Daoud. We're here with Erik Davis, and we're speaking today with Dr. Robin Carhart-Harris about LSD. Hooray! I was wondering, I wanted to ask you a kind of question that's of personal interest to myself. So this story of a kind of polarization in the mind of human beings, between that chaos and order, is an old story. They talk about it a lot in all the Taoist material, a lot of the meditation stuff, Hindu stuff, all the alchemy material seems to talk about it, how there's this like dragon or reptile, chaotic primal mind, and then our ordered self, right? And we're kind of like split into two. And a lot of the goal, seemingly, of a lot of these techniques or religious things that you can do seems to be to unify those two into some magical third greater thing that somehow expanded. So in those stories, sometimes you'll read, some people have theories that it's the hippocampus, right? That the amygdala, those little red beady eyeballs on there, are your chaotic, primal, like needy self. And then up at the top, you have this kind of point that, some people think can be that order maker. So I was just curious if in the trials, when you would kind of see this increased activity, if the behavior of the people, if their minds seem to be getting more ordered, more kind of in balance maybe, not to one extreme or the other, like you mentioned, because they both have their problems. But if they can get to that kind of middle place, did you see people's responses? Were they like emotional? Did it have results for them psychologically? Did you guys pay attention to that? Or was it more just trying to see like what the images looked like?
Yes, there's a lot there, but
yeah.
I mean, what we do is look at a relationship between people's psychological reports or their subjective reports and what we see in terms of the changes in brain activity. So that's always been the kind of primary approach in what we're doing in trying to find out how these drugs work in the brain. So we try and look for relationships between some measure of psychology and some measure of brain activity, essentially. And generally speaking, what we found is that the more intense the drug effects, the more marked will be this disorganizing influence of the psychedelic on cortical activity. So that if you want the more scrambled the activity, the more intense the drug effects. Now, it's very easy, I would say, to read too much into most aspects of brain activity. I wouldn't make too many leaps about what a particular effect is, but what I would say is that I can elaborate a little bit more and embellish a little bit more. Is that the right word? Or expand on what I've been describing so far in terms of psychedelics just causing a general disorder in brain activity, and the way I could do this, I hope effectively, is to describe two main principles. So the first one is what I would call disintegration. And so the function of any hub structure is to integrate. It's to have an integrating influence on the functioning of the system. And if you affect that hub structure, by implication, you may cause some disintegration. And there are a number of different networks in the brain or systems in the brain that seem to be involved in a number of different functions. So, for example, you have a visual system or a visual network which is concerned with visual processing. Similarly, you have an auditory network or auditory system which is involved in auditory function or hearing. You have a motor system for movement. You have a sensory somatosensory system for sensation. And we have a number of these different networks. And if you look at the integrity of these networks under a psychedelic, you'll find that integrity, how strongly glued together the bits of the network are under a psychedelic, you'll find that the integrity is decreased under the psychedelic. So the glue begins to sort of melt or dissolve, and so does the network. It begins to dissolve. Now, one of these networks seems to be exciting a lot of interest in psychology and neuroscience at the moment, and that's referred to as the default mode network. Very broadly speaking, the default mode network, which includes this PCC region I was talking about, seems to be related to very high-level cognitive function, perhaps also physiological function, but it does seem to be related to high-level cognitive function, high-level psychological functions such as self-reflection, self-consciousness, if you want. Also taking another person's point of view, which we refer to as mentalizing or theory of mind, which is related to being empathetic to some extent. Also imagination, introspection. So these very high-level functions, which are generally associated with what we do when we sort of disengage from the outside world and experience a kind of mental inner exploration. Now, this network, this system, the default mode network, has also been related to the sense of self. So when people are encouraged to reflect on their personality characteristics, for example, you'll see an increase in activity in this system or network. Actually, what we found with psychedelics, as I've said, is a kind of disorganizing influence and a dissolving, a disintegrating influence on this default mode network, as well as other networks, but on this default mode network. And actually, when we look at the magnitude of this dissolving or disintegration in the default mode network, and we look at the relationship between the magnitude of that dissolving and people's ratings of the dissolving of their self, their sense of self, or their sense of ego, we find a strong relationship. So the more that the default mode network is dissolved, the more people will rate having experienced this ego dissolution or disintegration of the self or ego. So for that reason, we think that that's some evidence to support the idea that this default mode network is, at least to some extent, related to the sense of self, to the ego. So that was one principle, disintegration.
Wow.
There is another one. I don't know if we have time for me to explain that one.
No, go for it.
Okay, so the other one, it took me a while to sort of settle on a word to describe it, but I would call it desegregation. And I quite like this word because it has sort of political connotations as well in terms of racial desegregation. So you could think of an apartheid system where races are kept apart, whereas what we see with psychedelics is that there's a unification, if you want. And so let's imagine in our mind's eye all these different systems or networks in the brain. I described a visual system, an auditory system for listening, motor system for movement, somatosensory for bodily sensations and tactile sensations. And the default mode network, we've also got a network for attending to things, for focusing on things in the external world. And so all these networks are quite separate, and they need to be separate because they need to do their own specific function. If they weren't sufficiently separate from each other, then we wouldn't have differentiable functions, and we'd start to confuse functions. Like we might start hearing things that we see, confusing our senses, and actually that's what you see with psychedelics. It's something which is described as synesthesia, or the mixing of sensory modalities. So the principle of desegregation is that these networks that are normally distinct from each other, normally separate from each other, begin to sort of collapse on each other and become just one larger system rather than a number of different separate systems. So that's what I refer to as desegregation. Now that relates to something that we published recently, which could be described as this is related to the effect of psilocybin on the brain, but actually in preliminary analysis, it looks as though we're seeing the same thing with LSD. And this is, like I said, it's related to this desegregation principle, but it's that regions in the brain that normally don't communicate so much begin to communicate more under these psychedelics. So there's an increase in novel communication patterns, novel pathways of communication under psychedelics, it seems.
I want to compliment you on the word. I know that it's hard to, every word you use creates a different kind of a set of associations, and it's a really great way of approaching that commonly reported experience of unity or of which doesn't really get you very far, but desegregation sort of has this more active sense of things coming together, or also a more spatial metaphor. You can kind of think of sort of superimposition as different systems begin to kind of overlap, and then they become sort of coherent in an interesting way. And it's so key in your description of this phenomenology, because on the one hand, if you have a kind of disintegration of a central hub, then the sort of, oh my God, it's just a bunch of chaos. Everyone's just going crazy. Oh, it's psychosis.
Yeah.
And you're back in that model of like, oh, it's just about sort of breaking down the fragile coherence of human subjectivity. And what you're also suggesting is simultaneously there are other forms of integration that maybe they're more open-ended, maybe they're not as controllable, maybe they're still unsettling to the coherent self or the ordinary everyday self, but they do point to forms of integration and deep patterning that in a way offset to some degree the disintegration.
I think that's true, and I mean, I think in a way we see disintegration in one aspect, but as you suggest, we see greater integration in another aspect. We're seeing integration in terms of communication between systems that are normally don't communicate quite so much. So the it's a bit of a leap, but I think it's an interesting one. There are a number of studies that have shown recently that there are enduring psychological effects of psychedelics, things like changes in well-being, changes in personality, specifically changes in the personality trait openness has been seen with psychedelics. And when we think around the sort of sociological, socio-political kind of associations with psychedelics, we do think of things like the counterculture. We do think of aspects of, to some extent, anarchy or questioning of authority. But we also see things like the promotion of unity. So these kind of liberal ideas and liberal ideals. And it's just interesting. It's a hypothesis at the moment, but it's one that I think is quite appealing. Is that what we see under the drug acutely or during the actual? I know it's a loaded term, but in terms of the actual psychedelic state, if we see this desegregation, for example, in the brain during the psychedelic state, is there some residue of that effect which persists after the drug experience, which may explain some of the personality changes, some of the more enduring psychological changes that have been associated with psychedelics? Now, that's a very dangerous, perhaps, and challenging idea, but nevertheless a fascinating one, I think.
No, and I appreciate you taking the risks, and I mean, I realize it's another thing you carry on your shoulders a bit is when you're you're a researcher, you have an institutional position, there's a lot of pressure to be very careful with the speculation and to be very clear about when you're speculating and when you're not, and when you're talking about the data. And I just want to acknowledge my appreciation for your willingness in this conversation and other interviews and videos you've given to, gently suggest some of the speculative and psychological and medical possibilities, even though they kind of step beyond the literal data that you're working on. It's not an easy line to walk, but I think, with psychedelics and with other kinds of research, often I find scientists are a bit too cautious on those lines. As long as it's made clear where we enter into the speculative territory, I really appreciate those thoughts. We only have a few minutes left, but even though it's opening up another door, I did want to ask you one question, which is that, as you mentioned before, your early interest, partly through your studies of psychoanalysis, which is already interesting for a neuroscientific researcher, was your interest in dreams. And I noticed that you had a recent paper with Dave Nutt about some possible connections with the same sort of brain region. So I'm just curious whether, again, in a, if you will, speculative mode, what sort of connections you're starting to see as between the sort of psychedelic research and the research, what it's saying about the brain, and possible connections with dreaming.
Yeah, so this in a way is my sort of favorite topic to some extent, and it's kind of what first drove me to contact David Nutt to try and do some neuroscience research with psychedelics. And really it was born out of an interest in psychology, reading literature such as Stanislav Grof's writings on the LSD state, which, if anyone's interested, is absolutely fascinating material, and I'd strongly recommend it. It's a little esoteric in places, but nevertheless, it's really rich and fascinating, I think. But in the book that I read, Stan Grof's book, he was saying that the LSD state shares a lot of similarities in terms of the phenomenology or the psychology to dreaming, and Freud famously said that dreams are a royal way or royal road to understanding the unconscious mind. And the same can be said of LSD, and if anything, LSD is a better way to understand the unconscious, because you're not asleep and you don't report your experience afterwards. So you're experiencing it with a higher level of consciousness, I suppose. At least in terms of being awake. And so and then it's what you call, in general, a convergence of evidences, and when you get that convergence, you usually think you're onto something. And so, to give you a bit to say a bit more about that, for example, there were some studies that were done in the 1960s that showed that if you give LSD either during sleep, so if you actually infuse LSD intravenously during sleep, you'll induce dream sleep and also induce dreaming. So after waking people up, they report particularly vivid dreams. And also, if you give LSD just before sleep onset, so probably before they've started to feel the effects of LSD, but they'll drink a cup of water that will contain LSD, and then they fall asleep as they normally would at a normal bedtime hour, and then they'll again go into dream sleep more quickly than they would ordinarily. So these studies, I think, are kind of suggestive of a relationship between the LSD state and dreaming. And then, if you look at there needs to be more work, I would say, on dream sleep and the neurobiology of dream sleep. Some of it's actually a little dated now, and we've got I think fMRI could be utilized more to understand dream sleep, or rapid eye movement sleep, which is the stage of sleep in which dreaming is most vivid. The problem is fMRI is very noisy and people don't sleep very well in the scanners. But nevertheless, some aspects of brain activity that we see, some aspects of the changes in brain activity that we see with psilocybin, share some similarities to what you see in dreaming. So, for example, changes in activity in these hub structures like the posterior cingulate cortex, and in dreaming you see what could be described as an increase in metabolism and blood flow in centers of the brain that are concerned with emotion. They're more primitive centers. These seem to be especially activated and engaged during dream sleep. You also see changes in brain activity with psychedelics in these centers, which could be consistent with what you see in terms of changes in or increases in metabolism and blood flow.
Well, we're going to have to wrap it up there, but that's all really exciting, and I congratulate you. It sounds like you have a very interesting career in front of you, and I'm glad that we're finding new ways to fund these studies. And I just wanted to let people know again that if they're interested in helping to fund this study, or at least just to check out more about it, you can go to wallacea.com. That's WALACEA.com, and the campaign is called LSD. So check that out. But Robin, thanks so much for joining us on Expanding Mind. It was fascinating.
It was a pleasure. Thank you very much.
All right. For me and Majid, all you out there, keep your minds open.